Hey guys, today we will be starting with the object-oriented programming part of Java. There are a few concepts that I want everybody to understand before we start to code today. And as I said earlier, that we'll code half the time and you'll be working on your milestone the other half the time. So the definition of the word class comes from the word classification. In biology, for example, when we use the word classification, what exactly do we mean in science? Categorizing something, right? So in programming, a class is more or less like a blueprint. What is the idea of a blueprint coming from robotics? How do you define blueprint? It's a design, it's a template. It's a vague idea of how things will be like. How many of you have a driver's license? One person, okay. All of you have student IDs, correct? Okay. At least, except for one person, everybody is in the same school, so all of your student IDs look exactly the same. What is the difference between your school IDs? The information that is on the school ID. Now, since you are in a different school, you have a different school ID, but everybody who is in that school has the same school ID. So what we do as a school, we create a template. That this is where the name will go, this is where the ID will go, this is where the picture will go, this is where the school logo will go. All of that information, when it comes to Java, is called class. It's a template. Okay, so template doesn't has any values filled in. It's just placeholders. So the values will change. However, the look and feel will be the same. So class is the template. When you start talking about each individual, for example, if we talk about Hamza, or if we talk about Mustafa or Inaya, they are specific implementation of the main idea. We call that an object. So object is specific implementation of a class. So for example, if I say Ash's school ID, so Ash's is an object of the classification called school ID. Alina is an object of the classification called school ID. So if there is a classification called marker, this specific marker will be considered what? An object. Okay. So when we created the marker classification, we came up with some properties. Okay, now look around you. For example, this whole pile of items in front of you here. What is the classification? Chromebook. Okay, what is the classification? All-in-one desktop. All-in-one desktop. It's a desktop. All-in-one means it doesn't have a separate tower. Everything is built into the screen. So monitor has everything in it. That's why it's called all-in-one. So classification is always a generic idea. So marker is a generic idea. So when I'm in the marker producing business, I need to come up with some properties of a marker. A common property for a marker would be color, price, right? The most common properties. So when I start producing this particular marker, what do I say now? The color is red, and the price is whatever I said, $1.50. Okay. Now, when I'm producing this specific marker, I'm saying color is price. Color is and a price. So now, how many objects do I have? 3. And they all are on the same classification called marker. Okay. So when the libraries are produced on classification. So they may create a library, they may create a classification called motor. Now, the same classification is implemented by your robotics team and every other robotics team. They will create a classification called motor. But after that, when they start feeding the values in, now they are working on an object which is specific to their motor, or you're talking about specific to your motor. So the libraries have classifications. You write these specific implementations. Now you look at the library and you're like, huh, it is missing this component that I need for my robot. So now what happens? You start writing your own classification, and then you start writing your own objects for the classification. So library gives you only a handful of classifications. You use those classifications to create your objects. But if a library is missing a classification that you need for your robot, now you need to write the classification and then create the objects. Does that make sense? Okay. So this can be implemented anywhere and everywhere. So when we are doing programming in object-oriented world, for example, if I'm given a business problem and a bank comes to me, let's say Chase Bank comes to me and say, I want you to write an application for me. My first question to them will be, give me the list of your objects. Walaikum assalam. Who? Nobody is here for coming down. Okay? Thank you. So Chase Bank has asked me for a list of items. And I said, okay, give me an object list. So they give me objects. One of the objects could be an account, an employee, a customer. So I said, okay, now what kind of information do you store about your employee? So they say, okay, we need to store our employee's number, name, address, their social security, the number of hours they have worked, if they're hourly or if they're salaried. So what I'll do is when I'm drafting the classification called employee, I need to know all of these things as properties. Okay, is everybody clear about the properties? Okay, the next important thing we need to worry about is behaviors. Every object has a behavior. These behaviors are also called methods of an object, as properties are also called attributes. Okay, now let's go back to your bank example. So I have an employee as one of my classification. I have a customer as another classification. So for my customer, I need to know what kind of bank account have they opened. Like, is it a checking account or is it a savings account? How much money they have? What is their account number? Right? All of these are properties. Now, what are some of the behaviors of a customer? I want to be able to withdraw money. That's a behavior. I want to be able to deposit money. I want to be able to check my account status, like how much money I have, like a balance, right? So all of these are considered as behaviors. So what is a behavior? A behavior is a set of code that goes against the properties and report on the status of the properties. Okay, so now by status, I mean you can change a value of a property. You can decrease it, increase it, or simply read it. Is everybody following that so far? No? Okay. So do you understand properties? Okay. Do you understand a behavior? Like, what is a behavior? Or do you need me to explain that again? Okay. So behavior is an action done by a class on the property. And that action could be to read the value of a property or to change the value of a property. Okay, so a behavior is done by the object on the property to change or to read. So when I say change, change could mean increase it or decrease it or change it to a different value. And read it is simply to tell what is it. So in terms of a bank account, anytime I make a withdrawal, what am I doing? I'm reducing the value of amount. Anytime I make a deposit, I am increasing. Anytime I want to check the balance, I'm just simply reading it. Clear so far? Okay. Now let's say I'm in marker selling business. So every marker I sell has a color and a price. Between the two properties, which property is more open to change? Price. So let's say I'm running a sale event. So what am I doing? I'm saying all my objects now, whatever their price is, drop it by 10%. So all of the object, anytime an object gets red, which is a marker, the price needs to be slashed to 90% of its previous value and then displayed on the screen. Okay. Now the behaviors are categorized into 4 categories. The behaviors responsible for changing the values of a property, they are called setters. Okay, they set the value. Yes.
These setters would be, in your example of putting the markers down to 10%, the setters would change the price.
The price, exactly. Or in case of any other object, let's say a bank account, the setter will allow me to change the amount in the account through a withdrawal or through a deposit. The second kind of a behavior is allowed to read the property, which is called a getter. The word getter is more or less like an object-oriented term, but this is more like an English term, read. Anytime I want to read a property, I will code what we call a getter. Anytime I want to change, what I'll code is what's called a setter. So getters are methods which start with the word get. Setters are methods that start with the word set. There is no hard and fast rule in Java to do that, but Java developers have this convention of writing their code this way, just so that as soon as I look at the name of the method, I will know exactly what its purpose is. Okay. Now, another writing convention is if my getter is supposed to get the value of price, I will call it get price. So right away, if a Java developer looks at it, he says, oh, this method is responsible for reading the price property. So it becomes so much readable. Similarly, if I say set price, that means this particular behavior is responsible for changing the price. So it's only for code readability purpose. Otherwise, the names of the methods do not need to start with get or set and do not need to be named after the property that they work with. It's just for readability purpose so that as soon as I read it, it just makes sense to me what the purpose of this code is. Now, since there are methods, we need to have parentheses next to them. Okay, is everybody okay with this so far? Okay. Now, so these are the 2 different kinds of methods, read and change. What is the third kind of a method? The third kind of a method is called constructor. Constructor. Okay, I'll explain what a constructor is. So when you first load the marker in the memory, you want marker to have some initial values. So anytime an object is loaded into the memory, the initial values or the very first set of values for all its properties, that's a responsibility of a special method called constructor. So constructor's job is to feed the initial values into an object when it first comes into the memory. Okay, so for example, anytime I produce a marker, I want the color to be set to black, and I want the price to be set to $1. That's my initial pricing. And then after later on, I will want to change it to whatever color I produce. Or I want to start with white, or I want to start with no color, whatever I want. And then later on, as the actual marker gets produced, I'll want to change the property of its color to that value. Now, in some businesses, they charge you different amount of money based on the color. So it's the same product, but just because it's a red color, the price is a little bit higher if it's a white color or black color. So depending on how hot the commodity is, so what they do is they start an object with an initial pricing, and then after the finished goods are produced, then they alter the pricing. Similarly, if you have ever built a car, what do? They start with a base car. And what do they let you do? Add features to it. So as you're adding features, what happens? Every time you add a feature, it is constantly calling set price. And each feature that you pick, the amount of that feature is passed as a parameter. So setters always have some kind of a data type and a value. Getters never have a data type and a value because getter's job is to read. Setter's job is to change. So setters always have a placeholder where they can accept a value from outside. And since setters don't return anything back, setters are always void. And getters always have a return type. So they're value returning, something we learned last week. So getters are always value returning. Setters are never value returning. Getters never take a value. Setters always take a value because that's what they change the value to, or they increase the value by. So whatever that is. So anyway, what is the job of the constructor? To give initial value to an object. That's it. So this process of giving the initial value to an object, there's a terminology for that in object-oriented programming. Ashas, do you know the terminology that we use when you are giving the very first, maybe you know, probably you are not remembering it. Have you heard of that word before, Ashas? Instantiation? No? Okay. So instantiation is a process for loading the object with its initial set of values. That's why when an object is created, an object is also called an instance. An object is also called an instance. Yes. No. Not class. When the object is loaded into the memory, when you load it with the very first set of values, the initial values, that whole process is called instantiation. An object is also called instance.
No, the constructor does that thing with the name of it for the class and the object.
So yeah, constructor is a method that does it to an object. But what happens to the object is called instantiation.
Class, the process.
And the class is a template, it's a blueprint. Object is a specific implementation of the template. And loading the object in the memory the very first time, that process is called instantiation and is done with the help of constructor. So these are very closely knitted terminologies. But there are different terminologies. So one of the ways to understand an instance could be that your main idea of a marker is the main object. And instance, what is the definition of the word instance in real life outside of programming? An occurrence of something is called an instance. So a red marker is a specific occurrence of the idea of marker. Now, so we have setters, getters, constructors, and there is a fourth category of methods called auxiliary methods. Auxiliary methods are anything extra that the class wants to do, which is not to do with setting the property, getting the property, or loading its initial values. The auxiliary methods are any general purpose methods that the class would use for any of its jobs. For example, if the class is about scores and it creates a method average score. Now, average score is not changing any specific property of any of the objects. Is the average of all the scores. Is nothing to do with setting a property, getting a property, or initializing a property. So that method would be categorized as an auxiliary method. Or if a class is a method, okay, print report. So print report is neither changing a value nor reading a value or initializing a value. It's an operation that is done on a collection of values that all these values are printed to the printer.
So for example, with downloading a
Yes.
document would be-
Yes, an auxiliary method. Yes, exactly. So anything that doesn't specifically work with a property or a specific object in particular would be considered as an auxiliary method. So these are the 4 different categories of methods. If you remember last week, Thursday, all the methods we created had the word static. Static methods mean that there'll be only one copy of that method in memory. But when it comes to objects, you cannot work with static methods. Why? Because if I'm creating 3 markers, each one of them have different colors. If it's a static method and I say the color is red, everybody will be red because it's one copy in memory. So what we do when we're creating these methods, we drop the word static, which makes them non-static. So non-static means each object will have its own copy of the method. So when I say I want to change the color of the marker 1, so there is a copy of that method that loads in the memory for this marker only. If I say you are purple, these guys still stay red and blue because they have their own copy of that method in memory. Everybody maintains their own memories, so you don't share anything. So if you want to share something at the class level, that has to be static. If you want everybody to maintain their own stuff so that there is no sharing going on, then you create non-static by dropping the word static in the declaration of the behavior.
You could change static. Well, that's pretty simple.
Static methods are not meant to change a property of an object. If you try to do it, it'll give you an error. Because static methods cannot look into the object's memory. Okay, so each object will have its own memory. Static method is in the memory of the class, not in the memory of the object. So it cannot see that far. Okay, so that's why you need to understand it a little bit differently. Let's say, so I have marker number 1, marker number 2, marker number 3. Sadik, it was your question, so you should be paying attention. And each marker has 2 values. The marker's color and a marker's price. These are all controlled by non-static behaviors. So when I want to change the marker 1 from red to an orange, I need to say M1 dot. So I need to give a context, whose memory I want to read. I want to read the memory of M1. M1, I want you to set the new color to orange. So it knows exactly to go to M1's memory and then change the previous color to orange. That way, M2 and M3's colors are not affected. But if it's a static method, you do not need the object reference. You can just directly call the static methods because static methods cannot look at the memories of each individual objects. There is another memory, a big memory, that is the memory of the class. That's where all the static methods live. They cannot see here. If they want to peek here, they need to know I want to peek in the memory of M2, and I want from M2 to give me the price. They cannot just say get price. It will not let them access because it will get confused. The computer will get confused. You want to get the price of which of the three guys, M1, M2, or M3, if you just say get price. So you need to give the context, then the method. Okay? So is everybody okay with these concepts? So far, if you look through this list, we went through create and instantiate, define and use fields. What's a field? It's a property or an attribute or a field. Multiple words mean the same thing. Just like parameters are also called arguments. Implement constructor. So I told you what is a constructor to initialize the values, getter and setter, and then look at the last few lines. There is a class called robot, for example. My robot needs to have a name and my robot needs to have a speed. So I decide to create two properties called name and speed. Okay. Then, if I want to create a robot, which is called instantiate a robot, this is the line I need to write in the main. Robot, which is the name of my class. Robot1, which is the name of my robot, equals to new, means I want to get a new memory so I can load all the properties of robot in it. That's why I need the word new there. And the last robot, can you see the difference between the first robot and the last robot? The one with the parentheses, that's a constructor call. The one to the right is a constructor call. The one to the left is a class name. So why are we calling constructor? Remember, it is the constructor that instantiates. It loads the initial values into the memory. So what we're saying is, Java, I want you to create a memory called robot1 of type robot, and I want you to contact robot constructor to fill it with its initial values. So if I want my robot to have a name of A and a speed of 10, it will be that constructor will do that. So all the constructors always have the same name as the name of the class. That's the property of a constructor. As soon as you see something like a class name with a parentheses, that right away is an indicator it's a constructor. No other method can have the same name as the class, but the constructor, even to the case. So if my class is motor, my constructor will be motor. If my class is marker, my constructor will be marker. If my class is an employee, my constructor will be employee. Okay? And this is the only method in Java that starts with an uppercase letter. If you remember my getters and setters, notice I lowercase the first letter because it's camel case, but constructors, they have to match the class names, and class name starts with an uppercase letter. So everything is uppercase. I mean, like, and the first letter is uppercase. Okay. So we talked about static and non-static. So notice the last bullet point. When you're calling a static method, you call it by the class name. How can you tell math is a class name? Uppercase M. Okay, look at the last bullet point, display status. I'm calling it by a robot. How do you know a robot is not a class name? It's not an uppercase. So if it is not a class and you're calling a method by a name, that has to be an object, like M1, M2, M3.
Can't you name a class like these?
You can, but it's against the Java naming convention. Okay, it's pretty much like showing to MEC, an MCC school, and wearing all black when you have to be wearing your uniform. So it's you're clothed, but you're not following the norm. Okay? So it's like Java developers prefer that way, so that because it's a naming convention that everybody understand. I didn't mean to tell you guys that. Wearing all black. It was just on a regular school day. Okay, so that's what basically it is, that as soon as they look at the code, they will be able to understand. Because remember, when you write a piece of code, you will not always be the person who will be on that piece of code. You will move up the corporate ladder, or you may change the company and go elsewhere. Somebody else who comes after you, they should be able to read the code. That's why when your English instructor asks you to write an essay, they ask you to follow a certain format, right? And then everybody is following the same format. It could be probably maybe an MLA format, because they want everybody to adhere to one format, so it's easier to grade. It's easier to follow. Exactly the same way when we code, we could code it a million ways, but we follow a format. I happened to once teach Java from a textbook that was written by some PhD guy out of I don't know which school, but he wrote the entire book, and many places he didn't follow the Java naming conventions. He just wrote whatever. So it was so difficult to follow through his examples, especially his examples. Some of them were like 4 or 5 pages long. So you're reading through a method call, because he lowercase all his class names. So it was difficult to see if it is a static method or a non-static method. So I had to literally go back and had to literally follow through to see what is the naming convention. So, but if you would have followed the Java naming convention, reading through the code would be so much easier. But anyway, he had a PhD, and in Urdu we say PhD is Phira hua dimag.
So underneath static method, the example word math, that's the class because of the piece.
It's uppercase, yes.
But in non-static method, robot is.
The robot is an object. Okay. Objects can only call non-static methods, and classes can only call static methods. Because static methods are in the memory of the class, and non-static methods are in the memory of the object.
But you know how like we call that's the system, that match our random and all those ones that are uppercase. Those aren't.
Those are all static methods. Those are all static. Now, println is not a static method, because look at the sequence. What do you don't say system.println. What do you say? System dot. So out is actually an object declared inside the system class, and out can call println, and out is all lowercase. So out is an object. So println is a non-static method.
Well, math
Random is a static method because math directly calls it, and math is a class. So if a class directly calls a method, the method has to be static. If a class calls a method with an object in between, or if an object calls a method, it's a non-static. Like out.println or out.print. Okay. Similarly, if you also remember scanner.nextInt. So you use the scanner object. You don't say scanner with an uppercase S. You never call nextInt with a class name. You call nextInt with whatever object you create of a scanner type. So now it makes a perfect sense for you to look at scan equals to new scanner. Okay, I'm not writing anything here for now. Scanner is a class. Scanner is a constructor. Scan is the object. And new means I want to allocate new memory. Okay? So far, you are writing it. Now we are trying to put some sense into what you were writing. That's why if you need to call next double, you will say scan dot next double. So next double, is that static or non-static? Non-static, because you're calling it by the object name, not by the class name. Okay? Good? Okay. Have a look at this guy. This is how typically a constructor would look like. And a constructor has the same name as the name of the class. So let's say the constructor is robot. It takes two parameters, name and speed. Now here comes a confusion. What are the names of the parameters? Name and speed, right? Now let me go a few slides up. What are the name of the properties? Also name and speed. So computer gets confused when it sees the parameter names exactly the same as the property names. It doesn't know who is who. Then you will be like, why don't we change it? Well, again, Java naming convention. Java developers prefer not to use too many names. So what they do is this. If it's a name of a property, they precede it with the word this. This dot name equals to name. When you write it like that, computer now can understand that the word name without the word this is parameter. And the one with the word this is the property. Okay? The one with the word this means I want to change the value of this object. That's what the word this means. This object's name will be whatever name is coming through. This object's speed will be whatever speed is coming through. So they use the word this. So this is actually a built-in object, which refers to whichever object's memory you want to change. So they literally use the word this. This is like a typical getter. As I told you that getters, over here, guys, getters will always have a return type. So since I'm returning a name, and name is a string, so the return type is string. And then I say return name. Yes.
So the previous slide, when we did this dot name, that name was the property, right?
So yes, name is the property, and the value that is going in that property is whatever value is held by the parameter name.
So we're saying this property equals to the parameter because they have the same name.
Yeah, so we are basically saying this dot property name equals to whatever value is coming. So whatever value is coming from the variable name will be put into the memory of the property name. Now we are saying is I want to read whatever value is in the property name. Now notice the definition. We do not have the word static. We just simply said public data type get name. We do not use the word static. So when we don't use the word static, it knows exactly not to put it in the memory of the class, but rather put it in the memory of object. So all the getters will be having the return type. So if I'm returning speed, what will I write? Public int get speed, return speed. If I'm returning a robot's position or an x coordinate, for example, then I'll say, okay, public int get x, return x. If I'm returning a y coordinate, public int get y, return y. Whatever. So you only return one property in each getter. If I'm returning a student ID of a student, I'll say public string get ID, return ID. If I'm returning that person's score, I'll say public double get score, return score.
So in the one, so if you like run this, then it'll only give you either red or 1.50. Like
Yes, exactly. So you will have to have one getter for color and one getter for price. So every property will have its own getter. Yes. Very similarly, when you are setting, you will have one setter for each property. So if I'm setting speed, speed is an integer, So that's why I said public void, because setters don't return anything. So see, you have void set. The name is speed. It always takes a parameter. The parameter matches the data type of the property that you are changing. So speed equals to S. So setter's job is to change. Getter's job is to read. Okay, everybody okay with that? Okay, so now let's put it all together here. Now on the tab, double click and change the name from main.java to robot.java. That's the name on the tab. As a result, the main will also be changed to robot. So when you're coding in your VS Code environment, like actual coding, when you're building code for the robots, the class name and the file name must match. Okay, now we have two properties for the robot. What are the two properties? We have public string name, public integer speed. These are the properties or the attributes of each and every robot. I could create 10 robots where each one will have their own speed and their own name. Because again, I'm creating a template. So what are these? These are properties or attributes or fields, different names used for the same purpose. Next thing we need is a constructor. Public robot. So remember, the name of the constructor must always match the name of the class. So by default, I want the name of my robot to be Mr. X, and I want the speed to be set to 0. So anytime a robot gets created, those are the default values I want to be fed into an object. Mr. X, 0. Naba, are you following okay? Okay. Any questions about whatever we write or wrote this far? No? Okay. Now, inside the main, I will create an object. So object or an instance of type robot. So robot R1 equals to new robot. So what are we doing? We're creating an object called R1 of type robot. We are calling the constructor robot, so the values Mr. X and 0 are filled into the memory. So basically, when line number 12 runs, Java will create a memory block of size 2. The name of the memory block will be R1. In the first block, in that memory, it will put Mr. X. It's a string. And in the second memory block, it'll put 0. Okay. Now, if I want to display these values, I can say system.out.println robot name is R1 dot name. I cannot directly reference name because name is inside the memory of R1. So I have to say R1 dot name. Okay, everybody with me so far? Okay. Now let's create another robot. Robot R2 equals to new robot. And we will copy and paste. I will call this one R2.name. If you notice, the copy paste structure is very similar. The only difference is the name of the object is R2. So if I'm referring to the memory of R1, I'll say R1.name. When I'm referring to the memory of R2, I'll say R2.name. So everything has to be contextual. Now run it, and you will have two sets of outputs where the robot name in both instances will be Mr. X. Now comes the idea that let's create a constructor where I have a better control. I want to be able to set the name of the robot myself. I don't want all the robots to come up with the name Robot X. Did everybody get it this far? Okay. So now let's go back to our constructor, and I'll say, okay, constructor, you will now receive a parameter called name. So the user should be able to feed what the name of the robot will be. So as a result, Mr. X will be replaced by name. And this is where the confusion happens, right? Because on both sides, it is name. How do you differentiate? This dot name. So this dot name is the property, and this name and the name on the right-hand side is the parameter. Now let's fix this code. This code is not complete yet. On line number 12, I'll say, okay, the robot number 1 is flower, and robot number 2 is cleaner. So now run it. So you will see that robot name for the first output will display flower, and robot name for the second output will display cleaner. So this is how we can customize. So when you get your libraries, built-in libraries, you call the constructors, you need to go and read how customized your constructors can be. If they're customizable, you can feed the parameters, you can feed the values, and you can customize it however much. Okay. So when you are writing an autonomous code, you need to see, okay, what autonomous library code is available. Then you feed the parameters, and then your robot, when it loads into memory, start automatically acting based on the fed parameters. Okay? With me so far, everybody? Okay. Now, notice I loaded both objects first into the memory, and then I displayed them to show you that creating the second robot did not override the first robot's name. They both maintain their own memories. Abdurrahman, do you have errors? Yes. Oh, you didn't do the parameter part. Pull up to line 4. Inside the parentheses, write string. String snippet. Okay. Okay, now in both cases, my robots are currently set to speed of 0. So let's try to display that. Robot speed is R1.speed and robot speed R2.speed. Since I did not customize the speeds, they both will be at 0. So when I run it, R1, which is flour, will be at 0. And R2, that is cleaner, is also at 0. So we added lines 15 and 17 to display the speed of each of the robots. And since we did not customize it, they both are at the speed 0. Got it? Now, let's go up and customize the speed as well. So on line number 6, we will introduce int speed as another argument. On line number 6, now we have 2 parameters or 2 arguments, one for name, one for speed. So line number 8 will now say this dot speed equals to speed. So fix lines 6 and 8. So I'm customizing both items, name as well as speed. Now, after I do this, line number 12, flour is running at a speed of 12.5 and cleaner is running at the speed of 5.75. Will this work? No, because I have double and integer. That's a problem, okay? So let me move these back to int values to avoid any confusion. Okay, now let's run it. Now it says flour speed is 12 and cleaner speed is 5. So I was able to customize their speeds. Yes.
For business, it would be the same code, but on a bigger scale with like multiple. Boards and multiple-
Well, it will be the same code. You will just write many objects. Your number of objects will vary. The size of the code will be the same. Yeah, your outputs and everything will be scaled up according to, you will rather put it in an array and loop through it, which we will learn how to create an array of objects on Saturday. Okay. Is everybody good here? Okay. Now, typically speaking, Java developers never, ever let static methods directly access the properties. They just never do that. that kills the purpose of writing getters and setters. So for better code encapsulation, they typically create them as private entities. Instead of public, they're private. They're not open for direct access. Now change the word public to private and now run your code. So what is the benefit of having private? Private is accessible from within the same class, but not accessible from outside of the class. Public is accessible even from outside of the class. So they make it private, so it's locked into the class. So now what is a better way to access it? Through getters and setters, which are made public, which we will add to this code next. So here, after the constructor, we will add getters. And then after that, we will add setters. So after the constructor, I'm adding getter. So what is the syntax of a getter? Public, return type, get, property. Public, return type, get, property. So if you look closely, both getters are created on the same principle. Yes. You private the properties and you public the behaviors. You can private the behaviors too. So sometimes what happens in Java development is there are certain behaviors the developer writes for internal purposes and not to be accessed from outside. So create them as private behaviors. So other behaviors can call it, but other classes cannot call it. This idea is called, in Java, there's a terminology called access modifier. So these words, public and private, they're called access modifiers, means how far you can access the stuff. There is another one, which for those of you who make that far will learn, which is about inheritance, where we learn about protected access modifiers. Okay, so these are getters. Next comes the setters. Public void set name string name. This dot name equals to name. Public void set speed int speed. This dot speed equals to speed. Yes. Oh, thank you, void. So setters and getters, look closely, they are written on slightly different grounds. Setters always take a parameter and are void. Getters always have a return type and no parameter. So getters will always have a return, setters will never have a return. And once you understand this, you can create almost any class because they're all on the same principle. The benefit of having a setter over here is now I can change the speed of my robot anytime. I'm not locked into speed of 12. So what we will do is After I set the flower to a speed of 12, I'll say, you know what, robot? I want you to have a new speed set at 50. And robot 2, I want your new speed to be set at 15. So when you now run your program, you will not see 12 and 5 in the output anymore. You will only see what? 50 and 15. Where is Dania today? Now, missing this class is very, problematic because it's a milestone class. Like this is a different kind of information. I know it's getting recorded. I'm gonna post a recording maybe like tomorrow. So yes.
Does it matter? You know how we set the speed that we have?
So again,
You know how we changed the speed afterwards from 12 to 5 to 15? Does it matter that that is placed after the instance?
it has to be because otherwise it will not work because you can only change the speed after the object comes into existence. So lines 26 and 27 are creating two objects. Once they come in existence, only then you can change their speed. Similarly, instead of calling r1.name, I will call r1.getName, r1.getSpeed. Similarly, r2.getName and r2.getSpeed. So I changed all of the lines 30 through 33 by calling the getters. So a typical Java object or typical Java class would be written this way with the properties, constructor, getter and setter for each property, and then you will call it like this. What I want you to do next is I want you to open a new tab, which I'll call demo.java. Demo.java, public class demo. Robot RB1 equals to new robot. System.out. Oh, sorry, all gonna be gen 33 system.out.println rb1.name. This will generate an error. This will give you an error. I want everybody to be able to see the error message so that I can explain it to you and then we can fix the error message. So when you write the first line, we are creating a robot by the name of RB1. That's the name of the object. That robot's actual name is Jen, and the speed is 33. And when I say robot name is rb1.name, it right away gives me an error message saying, I can see the robot, I can see the RB1, but you cannot directly access a private property. To fix the problem, you will change it to rb1.getName. And then it will work. rb1.get name. Okay. So this is to show you that when you have multiple classes open in different tabs, they can see each other. Robot is not in this demo. Robot is a separate class. But as long as they are in the same session, they can see each other. So when you are working in the VS Code, all the classes can see each other. As long as you use the correct access modifier. Yes.
All like, specific object in the class, you don't have to call the class, you just have to call.
You call the class. On line number 3, I call the class robot.
Oh,
Okay, so I'm saying, now, if you mean import, no, I don't have to use import if they're in the same package. If they're in different packages, then I have to use import. Like when you will be using classes from the provided packages by the library, then you would write at the top, import so-and-so package and so-and-so class. Only then you can use those classes. Yes, but within your packages, yeah, you don't need to. Until and unless you divide your classes in different packages.
So on the PowerPoint, the example that it gave, it was public class robot, and then the rest of them, all the class, it was robot. So does the class, like, for example, when you use in line, does it have to match the name of the?
Yes, until unless the names match, it will not know what you're talking about, right? So the robot, if you're talking about the first word on line 3, and that must match the actual class name on the first tab. It does. No, not on the demo, the other tab. See, we're calling from demo the robot class. Yeah, exactly. We're calling between files now for the first time. So far, we were staying within a file. Now we're calling just like you would call in the real life. Yes. Oh, main is a method. Main is a method to start. Now, what I'm basically instructing Java now is do not call the main in the robot. Call the main in demo. So the main in the robot is not even called. Because there can be only one main in each execution. So typically what happens when you build projects, you only write one main in your first starting file. In all other files, you don't write main. So none of the files are runnable by themselves. So what we do is we test to make sure the files work, then we remove the main. Okay,